maybe we could assume that we always need to pass some sort of unit to it. That might be fine. All right, what if we implement some sort of like pathable unit or something like that? I guess maybe we should rename these to like Q tile or something, Q path tile. IQ. And this would be IQ path unit. So this has got some sort of interface. That's kind of reasonable, actually. I think I like that. Now, some of these games might not need to implement all these functions, but that's okay. So now we'll make the IQ path unit. So this is going to be another interface. And all it needs to do, namespace QPath, public interface, and it just needs to return a cost to enter hex. It probably needs to know both sides of the hex. So it's got an IQ path tile, source tile, IQ path tile, destination tile. Because again, if there's a river crossing or not, some units might get to ignore rivers, right? If it's an amphibious unit, for example, maybe rivers don't cost it anything. So it needs to know the two tiles here. We haven't implemented rivers, but if we do implement rivers, or when we implement rivers, you're always going to need to know from this tile to this tile, is there a river in between them? So that's why we'll always need to know the source and destination. It's also really easy to imagine a situation where maybe you have a game where if you're on a hill and you're moving to an adjacent hill, maybe the movement cost is just 1. Because you're already at the right elevation. So, IQ path unit over here interface. So our own unit is going to implement this interface, which again we'll need to resolve that. And yeah, it'll need to implement the interface. Okay, you're being weird, so that's fine. So again, it's just going to complain here. The unit. So it's going to complain that these things haven't implemented their various their functions over here. So we're going to make some changes to the functions that are here. So to implement that interface, we need something that's called cost enter hex. This and this. So we're just going to return 1 for now. Shh, it's fine. And all these costs, it should be noted, the turn cost to enter hex, i.e. 0.5 turns if movement cost is 1 and we have 2 max movement, right? That's the sort of thing it's supposed to return. So we'll just put in a 1 right now, just so that it's done, and that's going to be okay. And yes, how come you give me the warning about this? I don't care about C#6. Maybe it's because because I tried to implement the C#6 library at some points and it's confused. I mean, I might be able to still hit this and have it be okay. Looks like it's going to be fine. Okay, yeah, that's all right. So these are the 2 functions that we need for this tile to count as part of the IQ path implementation. So if we try to render now, oh, you don't implement that. Oh, because here it's got to be defined as actually public. Our unit, it's got to be public over here. Now you're good? Okay, now you're good. I mean, it's not working yet, but we've got it compiling, and we've satisfied everything. So these are the two functions we're going to have to implement to get the IQ path tile to work. Let's come back to this. Let's not implement it right now. Let's get back to our sort of QPath logic over here. Okay, so now we've defined that our tiles need to be able to return a list of neighbors, and the aggregate cost to enter this tile from another tile, like that. So clearly then, not only is this find path going to need our world, the starting tile, and the end tile, but something like the unit. The unit is a object that is the thing actually trying to path between tiles. It might have special logic based on its movement type and the type of tiles being moved through. I think that's pretty good. That's the chat. What the Q stands for cube because of the cubic coordinates. The pathfinding system will have no idea what the coordinates are at all. Instead, our world is going to have one more interface over here. Our world is going to have some sort of interface that allows the Q path to look up a list of tiles from some sort of mechanic. Q path actually won't really be aware of how our tiles are organized in the slightest, which is kind of neat. So here I'm going to reference the work done in Project Porcupine over here. So the idea is we're going to have some sort of function very similar to, yeah, find path. Okay, so let's go and implement this. We're going to have some sort of public, probably a static. Yeah, this is definitely going to be a static. You're not necessarily going to need to instantiate QPath. In fact, I actually think it's probably fine to assume that QPath will be static by itself. So we never instantiate this by itself. We just call QPath.findPath, and shit happens. We don't want to know the details. We just want shit to happen in the background and be done with it. So QPath is going to have a very, very, very simple interface for the world at large. As long as you give it the right type of objects over here that implement these required interfaces, it's going to take care of the rest of the work for you and not give a crap as to what else is going on. So, call it find path. And so, yeah, it's going to need, and we don't have it yet, but it's going to need something that is the IQ path world. I guess we'll just call it world instead of like our world, the unit, etc., etc. That's probably fine. IQ path unit, IQ path tile, start tile, and IQ path tile, end tile, like so. So we need to implement this bad boy. IQ path world. Which again is going to be an interface in the same namespace over here. And it's going to do something. I'll have to figure out exactly what we want it, but it definitely needs some sort of like get tile at kind of implementation, which it so happens our world, which is this thing called hex map, right? So hex map is going to be an example of, so it's still going to be a mono behavior. You can put a comma in here, right, for IQ path world. Oh, it needs to use QPath over there. So you can do both. So it's actually derived from mono behavior and implements IQ path world, and that's going to be a-okay. And it has this function here called get hex at xy. Most likely the interface is going to say something like IQ path tile get tile at. But that assumes a 2D like like a square sort of coordinate system, which may or may not be what we're looking for. It might also have something, you could easily imagine something like get all tiles, like that. You know, that one of these, something like that will be implemented, and then we'll have to implement the same thing in hex map, which might mean that we just replace get hex at with get tile at, or something like that, just to make it match. That could be the implementation, or one can just, you know, call the other or something like that. We'll see what we decide to do. But. So we've got the IQ path world. We've got this. It needs to return something. What is it going to return? Probably an array of IQ path tiles. Now, we might change all this to explicitly return a queue or a list or something like that, just to avoid too many like conversions between types. But for now, we'll assume that we're going to have an array. I mean, it's gonna return something like that. Ultimately, what it's actually going to do is return something that's enumerable. Like, I guess we could even just say, listen, we're going to return you something that satisfies the IEnumerable interface. That could be an array, it could be a queue, it could be a list. It's something that you can do a for each loop around. You know, maybe that's fine, but let's save that for later. Let's assume for now we'll return an array of IQ path units, and that's the entire function signature. We probably want to do some sort of like error checking at this point. You know, like if world equals null, or I mean, we might want to do it separate ones, but for now we'll just do it. Or start tile is equal to null, or end tile is equal to null, then debug.log error, null values passed to I mean, maybe we don't even want to check this. Maybe we just want to have it like run and explicitly crash. Like, you know, it'll throw up some sort of exception later on down the road. Dying loudly is good. We are missing a closing brace there. And this is not quite dying loudly in the same way, but it's going to be fine. What are you whining about? Not all cold paths return a value. Oh, yeah, you're right. That's fine. That's fine. So, I mean, we'll put another return null in here just to satisfy the compiler for now, and that's going to be A-okay. Oh, maybe not an array of IEnumerables. That's right. Maybe just an IEnumerable. Anyway, yes, that would actually... Yeah, so not an array, but if we went with the IEnumerable. All right, so now the thing is, at this point, call on our actual path solver, because it doesn't have to be an A-star solution. We might want to have a different type of path solver. So we will implement our actual path solver as a separate class. In this case, we're just going to have the one for the A-star, but that's okay. So again, we're mostly following the solution that was pieced together for Project Porcupine, but that's going to be okay. So we are going to have this thing called IQ A-star. IQ path A-star. There we go. I think I like that. Boom. Of course, I can't paste because MonoDevelop is terrible. But Visual Studios is not something a lot of people use, which is why I do it this way, blah, blah, blah. We have to explain that every time. This is the default, and it works on all platforms that Unity is available for. And it would just be way more confusing to people if I were to use Visual Studio, although it is excellent. So there we go. So this is the thing that's actually going to do the pathfinding work. But it might not be public. Like, we might not want you to be able to touch this from outside of the namespace. We'll figure that shit out later. That's actually very likely to be true, that this class won't be accessible from outside the namespace. But we'll figure that out after. So yeah, so this is the thing that's actually supposed to do the work. So the idea being that all this stuff that was passed in here is actually going to be something like IQ path A star, resolver is equal to new IQ path A star, and we're going to pass all this info to it. So this is going to have a constructor, public constructor that takes these values over here to do the actual work. The nice thing about this is that you can instantiate the path A star and, you know, again, feed it off into a separate thread. You could do all kinds of different things for it. And if we're going to follow the pattern that we had before, this is going to, so it's going to do some work somewhere in here. Do work. Or what we actually want to do is something like this, you know, so do setup. And then maybe we will actually want a function here that says something like, call it do work. This will be maybe a little bit easier to do the pathfinding for, or the multi-threading for. And then in the end, it's going to have some sort of public thing that this is returning the actual list of tiles, get list. Like this. So we do some setup. We do the actual pathfinding work. It stores the data, probably in something like a list of path tiles. You know, tile list, path, maybe something like that. And get list is just something like return path dot to array or something like that. Okay. Obviously, the path isn't initialized at this point. It'll throw up an error, which we might want. We might not want. We might want do work to return true or false if there's an error. We might want something of that nature. We'll sort that out later. But then over in path, what we do is we do the work, and then we return resolver.getList. And the upshot to this is we could have something that's not an A star to resolve our thing if we decide that that's what we want. Groovy? Groovy. We need to get rid of the things here. Cannot, oops. This is supposed to return an array of tiles, not an array of units. Groovy. All right. So now we'll actually implement A star, but again, this will mostly be a big copy and paste. So do setup. I mean, we'll assume that's going to be a new list or whatever. Maybe that should happen in do work or something like that. You know what? Let's assume something like this. Go away, warning. We'll store some of this data here. So all this stuff, we're going to store it as private variables. Because I think our setup's actually going to be basically nothing. Basically just storing this so that our do work has access to it. But we might end up doing some more. So this.world equals world. This.unit equals unit. This.start tile equals start tile. And this.end tile is equal to end tile over here. All right, so here we're going to do the actual function, and I'm going to start copy and pasting. It's worth noting, Wikipedia has an excellent pseudocode article for A star that you can follow. That's what we've based our work on before, and actually I contributed to that article to clean some stuff up because this was a while ago. It's probably been changed 30 times since then. But there were actually some issues with the algorithm the first time through that we discovered while doing the tutorial, and then I went and updated the article after the fact, which is really nice. So, really, the path here actually is legitimately going to be a queue, not a list. Very little difference between the two. Queue, though, is a little bit more accurate to define what we're doing because you add tiles to the back, and presumably it's got an internal data structure that is going to be a little bit more optimized for that. Not that it really matters too much, but really it's a queue of tiles that you're going to go through in some sort of order. We should... So one of the interesting things in Project Porcupine, we have the tile graph part of the world. So again, we need to create this graph, right? Which is, where's my Photoshop? Which is the definition of there's these series of nodes and they're connected by these edges. Now, while we're not going to be tracking the weight, well, we may or may not cache it. This is actually a time when we're going to set that parameter. I think what we're going to do, in Project Porcupine, we store that graph as part of the world itself. But I don't think that's what we're going to do here. Instead, I think our program is going to maybe develop a library, a dictionary of graphs for the world that it's going to cache, and then we can just have the Pathfinder, you know, ask for that. Can an interface define that it's also going to have like some sort of variable? I don't think so, huh? And I don't want our hex map to have any awareness of the graph. That's not something it should do. But I don't want to rebuild the graph every time we do a pathfinding. That would be terrible. So it's definitely got to stick around. So I think our QPath class over here is indeed going to have to remember our various graphs. Can I just make a file from here? Yeah, let's go and do that. New file, empty class here, IQPath, and it's going to have a graph. Are there going to be different types of graphs? Possibly, but we can probably just literally copy the same name as before. Oh, it's interesting. Default assembly over there. So this is going to be the Q tile, and probably we're going to need something else. I don't know. So this is going to need an IQ path world. Oh, QPath namespace. No underscore. Okay. I'm using these underscores because there might be different types of graphs. Same thing. So like with the pathfinding and with the graph, because there might be different variants of them. That's why I'm using that. It might lead to confusion that is stupid and bad, but for now it's going to be okay. So this is going to have the ability to create nodes and edges. Now our nodes are really going to be the IQ path tile. And the edges are going to be defined as two tiles, so tile A to tile B, plus a cost. And I think what we can probably do is have this just be a class that's within this. So something like an edge. And it's going to have a IQ path tile. I'm going to just call them A and B. That's probably fine. A and B. And it's going to have a public delegate float edge cost function. Let's call this edge cost. God, I can never spell this right. It gets worse every time. Edge cost delegate. Edge cost delegate. Boom. So this is going to be a function. Basically, you're going to be able to have an edge E. Hey, it's edgy. Then you're going to be able to say E dot edge cost, and this will return a float. The reason I'm doing it this way is because if we allow cost catching, so it's going to need. We're also going to need to pass in some sort of like the cost function. Oh, but this is. Yeah, we're going to need some sort of function here that we pass in that describes the cost between tile A and tile B. Now, at that point, it becomes very important. If the cost is cacheable, what we're actually going to do is we're going to run that function. So we're going to have some sort of function here, probably over here, and we're going to create a public delegate, which is going to be a float. This is just, we're defining the signature of a function. So it's going to be something like tile entering cost delegate or something like that. And, okay. I was planning to do this a certain way, but that was before I was planning on passing all the unit code in there. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cakeveen, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so, so much.